From our sum and difference identities, we get double angle identities. Here are three identities for sine, cosine, and tangent. Sine of 2 times an angle theta is equal to 2 times the sine of theta times the cosine of theta. I'm going to go ahead and prove this first one so you can get an idea of where these come from. So sine of 2 times theta, okay, we can think of this as sine of theta plus theta, and then use our sum identity for the sine. So this is the sine of theta times the cosine of theta plus, and then it's sine of the second angle, which is again theta, times cosine of the first angle theta. And we can see that those are the same things. So this is 2 times the sine of theta times the cosine of theta. Now, the process for the cosine and the tangent identities is almost identical to this. You just use the cosine sum identity and the tangent sum identity to get these two formulas. I should note that there are two other forms that are common for the cosine of double an angle, and that's simply by we obtained those by simply replacing cosine squared with 1 minus sine squared from our Pythagorean identity. So cosine squared of theta is 1 minus sine squared theta, and then we take that and subtract another sine squared, and that gives us 1 minus 2 sine squared theta. So this is another double angle identity for cosine, and we can do something similar with sine squared. If we take this sine squared and replace it with 1 minus cosine squared, we get cosine squared of theta minus, and then this thing here is 1 minus, cosine squared theta. And then when you combine these, you distribute this negative, and you get a positive cosine squared theta. Combined with this one is 2 cosine squared theta, and then minus that one. And so the cosine of 2 times an angle, we actually have 3 different forms for that identity.